Well, hey there everyone, and welcome back to Stuff in Excel. We're going to look in this video at how to do t-testing within the Excel environment. Now, a t-test is where you compare two different samples to see if they are significantly different from each other from a statistical standpoint. There are times when you might implement a new training procedure and you want to see if employees know more after the training procedure than before. There may be times when you implement a new quality control procedure and you want to see if errors go down after the implementation of the control versus what they were before the control. T-testing will allow you to make that determination and to get a feel for how significant that change is. So Excel gives you some tools that are really helpful at doing a t-test. Let's go in and take a look at them. We're going to start with this data. Now, a little background. On the last day of September, we implemented a new internal control. The internal control is meant to reduce the number of errors per 1,000 transactions. What we can see here is if we do this, let's just do an average. So say equals average. So if I take the average of the errors in September, we can see that we have on average 12.267 errors per day in the month of September. If I did the average for October, we can see that we have an average of, we've implemented a control to try to reduce the number of errors. And when we do that for October, we see that our number of errors appears to be an average of 9.267. So it would appear that that we have actually, if we look at the 30 days prior to the change and the 30 days after the change, it would appear that the number of errors has gone down per day. And so we want to see if that is in fact true. Just because we've got a change doesn't mean that it is a statistically significant change. This could have just occurred just by random. It's not a significant change. We didn't go to from 12 to 0, went from 12 to 9. So while the difference is about 3 points, the question is that difference not just impressive, but is it significant, statistically speaking? So we're going to need to do a couple of more tests. Now, the first thing I want to do is emphasize that anytime we do a test like this, we want to look at the data first. So we're going to highlight this data, Control-Shift down and over, and we're going to go do a pivot table on this data. So I'm going to insert, go over to Pivot Chart, and pick Pivot Chart and Table. And I do have headers, so it's got that, and so I'm going to click OK. And I'm going to look at my observation date, and I'm going to look at my errors. Now, it creates an actual variable here called month. We're going to take that out. We're going to move months up to filter. Okay. So if I just look at this raw data, just by month and by day, it's kind of weird. It doesn't tell me a whole lot. It goes up and down a lot. Let's look at a bar chart. Sometimes, or a line chart. Sometimes bar charts don't tell us as much as a different kind of chart might tell us. So I'm going to change this to a line chart and see what happens. And again, it's kind of all over the place, isn't it? It's up and down and up and down and up and down. And I don't know whether this is significant to me or not. Now, we can do an additional analysis on this. In fact, we can look at this by month. If I just want to look at September, I can see that September, I'm going to look at my filter, September kind of down, and it's got some downs. It looks like it's got a regular pattern of being down. That's interesting. If I go look at October, it also seems to have a bunch of zeros. Not quite as regular, but it's be interesting to find out what those are. So what we're going to do is go back to our original data. You'll notice that if I'm in a pivot table, I cannot insert anything in. I cannot insert a column into the pivot table. If I try to go right-click, insert, it's going to tell me it can't do it. But what I can do is go back to my original data. So I'll go back to my original data, and I'm going to first turn this into a table. So I just click anywhere in the area. I'm going to insert table, and it does have headers. Now I'm going to insert a column, and the column I'm going to insert I'm going to call day of the week. and I'm going to use my day of the week function. I've got a date over to the left, so I'm going to simply say equals text, and then I'm going to go to that observation. I'll get comma. I'll do equals DDDD and close the parenthesis, and it tells me the day, and it copies that all the way down. Okay, now if I go look at my pivot table, and I do a refresh, I'm going to click anywhere in the chart, and I'm going to do analyze and refresh data. And I don't want you to look. Well, let's look at what we got. We got this data here. We got our date. We've got our sum of errors. Over here, we've got the observation date, errors per 1,000 transactions, and months. So let's go see what happens when I refresh this data. When I do refresh all, you'll notice that over here in column A and B, nothing changed. But look what happened over here in our pivot chart fields. We now added day of the week as a new item. And I'm going to click day of the week, and it's going to put it down here in my axis. And I don't know how helpful that is to me, but if I switch these two, put day of the week first and then the observation date, look what happens. My Sundays are here, and look, every single Sunday is 0. Every single Sunday in the month of October is 0. And if I go look at September, I want you to see this. Same thing happens. Look at that. And if I looked at both months, every single Sunday is 0. Now, why would that be? Well, when we do additional investigation, we find out that this is a store that's not open on Sundays. Oh. Well, then maybe Sundays don't need to be in the mix, because when I do an average, let's go back and look at this. If I do an average here and it's got zeros, that's going to bring both these averages down, right? So if I take out the zeros, both of those averages should go up. And so what I'm going to do is I'm going to go over here and I'm going to move my day of the week up to my filters. And you notice right now, day of the week is it's down here. I'm going to move that day of the week up to filters, and now what I'm going to do is I'm going to take this is September, and it's got all the days of the week in it. Okay, it's got all the days of the week. When I take out Sunday, watch what happens to this data in September. The variability changes dramatically, doesn't it? Let's go back and look, see what that. If I watch out when I add Sunday and how the variability goes up, it changes. That's actually for both months. It changes. You can see how the variability changes. If I want to do just for 1 month, let's go back and put Sunday back in. Let's just go look at September. The month of September. There's the month of September. If I take out Sundays, because remember there's zeros, we don't, and we shouldn't have any errors on that day because we're not doing any transactions on that day. Look how the variability changes in that number. And then let's put that back in and go look at October. So if I put that back in, and now I go look at October, and I click down here and go look at October, there's October's data. Again, it's all over the place. If I take Sundays out, I take Sunday out, and it changed it a little bit, but I'm not sure it changed it a lot. But we did take the Sundays out, and you'll notice that over here, the Sundays are all gone. I go to, if I go look, let's put all the months back in. Let's add in September, so we'll just say all. When I add that in, September 1, 2, 3, 4 is missing. That's because that's a Sunday. 5, 6, 7, 8, 9, 10, 11 is missing. That was a Sunday. So the Sundays are now out of this data, aren't they? Because I took them out. I can put them back in. I can go in, click on Sunday, and it puts them back in. But if I take them out, which is what I want to do, now I've got data for all my working days without the Sundays. So let's go see what happens. Now we can observe one thing. Notice in September we had no days with 0 errors, but we've got at least 2 days with 0 errors in October. Let's go see if that's a significant improvement. So now I'm just going to click anywhere in this, and I'm going to go to Data, and I'm going to go to Data Analysis. So I open my Data Analysis Toolpak, and I'm going to go down to something called t-test. Now it's going to show up for you up in here. I'm going to go down to t-test, which is down near the bottom, and I'm going to do the 2 sample, assuming that equal variances. So I've got 2 samples. There's no reason, normally, there should be no difference in the variation between these. Let's just see what happens if we say there's unequal variances, which we know now because we can see that the variances are not the same. So let's go look, let's click OK and go look at the t-test for this. It's going to ask us, first of all, what's our first data variable range? Well, I'm going to highlight from September 1st all the way down to September 30th. And then for my second range for variables, I'm going to highlight from October 1st all the way down to October 30th. Actually, October 29th, because the 30th was a Sunday. And I expect the mean to be the same. My null hypothesis is that the mean is no different from one to the other. So I'm going to hit 0. Whoops. Down here in this box, I'm going to hit 0. And we're going to use it at the alpha 05 level. And we'll click OK. And that's hard to read this, so I'm going to click on this triangle. I'm now going to expand my columns. And look what I've got. I've got a mean that has changed. It's gone from 12.267 to 14.15. And my second variable, my October variable, has gone from 9.267 to 11.12. Now again, it's about the same as it was before. The difference is, but what we see is the averages are higher because we don't have the zeros. So let's ask ourselves, is this difference statistically significant? Is it meaningful? And when I look at my p-value for a one-tailed test. Now remember, in this case, we would expect the change to cause us to have fewer errors. So it's a one-tailed test. We're only interested in one direction. And what we find out is the error is the p-value is 0.029. Remember our rule. If the p-value is less than the alpha value, which in this case was 0.05, then we reject the null hypothesis. We say that these are not the same, that in fact there is a difference here that is significant and that is not likely to be random. If we look at the two-tailed test, it's not quite as clear. It's 0.058. It's much closer to the 0.05 alpha, but the one-tailed test, this lower p-value is much more significant and much more meaningful than the p-value that is slightly greater than the alpha value of 0.05. So in this case, we would probably reject the null hypothesis. We would assume that in fact our control is working the way we want it to. It's reducing the number of errors per 1,000 transactions.